in that table is, if you notice, they're the exact same on the left and right, the terms. Like this one on the left is 3m squared n cubed, 4m squared n cubed, and it's the same thing on the right-hand side. The only thing that's changed is everything on the left side is add or subtract, like we did yesterday, and like you just did on your warm-up. But on the right side, it's being multiplied instead, and we're going to talk about how that the answers change from one to the other. Okay, so the terms are the same. Here we're adding, subtracting. Here we're multiplying. Right. So on this left-hand side, fill those in real fast. Do you know how to do those? We just did that on the warm-up. Do those additions or subtractions on the left-hand side real fast. I hate when I say the exact same thing twice. I hate when I say the exact same. No, I'm just kidding. So you should have 7m squared n cubed, 4x squared. And how come I didn't do anything here except rewrite it? The exponents are different, okay? Now, for yesterday, there's nothing you could do about that if the exponents were different. You just leave it like it is. But for today with multiplying, that actually doesn't matter. Do you remember what you do with exponents when you're multiplying? You add them, right? Because what's going on is that, like, let's say you had x to the third times x squared. What that means is 3x is here times 2x is there. And how many x's is that altogether? 5, right? But we don't want to have to write it out like that every time. So we just have the shortcut rule. Just add the exponents, and then you're good to go. Right? So, for example, on this bottom problem, when we were adding, there was nothing we could do. But when we're multiplying, we actually can do the math. You do the math on the coefficients. Negative 4 times 3, you do that. Negative 12. And then you add the exponent. So it's x to the 5th, all right? Couldn't do anything about it when it was addition, but we can do something about it when it's multiplying, because the rules are different. Going back to the top problem, 7m squared n cubed. Don't change the powers when you're adding, but when you're multiplying, here's how that would look. You do, in each chunk, you do the math. Like, for example, you do the 3 times the 4, because those are like terms. That's 12. And then you look at the m's next. How many m's are there altogether? 4. And then what about the n's? 6, okay? And then what do you think this last one is? What's that answer? Negative 12 x to the 4, okay?
So we only add the exponents when you're multiplying the whole problem?
Yes, I love what you just said. So we're going to write that in our takeaway section. You only add the exponents when you're multiplying. What's something similar you could say about when you're adding or subtracting? What would you say? What do you do with the exponents then? You keep it the same, right? Keep exponents the same when adding or subtracting. When add or subtract. Tomorrow we're going to be dividing. Do you remember what to do with exponents when you're dividing? Subtract them, right? And then Thursday we're doing long division. I just thought I'd give you a heads up about that because now you'll be excited for Thursday. I know how excited students get about long division. I don't want to deprive you of that spark of happiness. Okay, so what we're going to do now is a bunch of multiplying. And we're going to start, and this is going to get like progressively just longer problems. Not harder, the skills aren't going to get harder, just the problems get longer. But we're going to be able to handle it. So this first section, method 1, is just distributive property. You have something outside parentheses, and it has to be multiplied by everything in there. So distribute. Negative 2y times 4y squared. You do the negative 2 times the 4, that's negative 8. And then add the powers on the y's. So you have y cubed. And then you take the negative 2y times the middle term here, the positive 3y. So that's negative 6y squared. And that's fine. But when I take that negative 2y to the last term, there's no y on that one. Yeah, you just add the y at the end. You just tack it on. You just smush it. So it's still negative 2 times negative 5, which is positive 10. And then that y, that's with the 2 out front, you just put it on the end. So anytime you're multiplying variables and one term has it but the other one doesn't, you just smush it at the end. You just tack it on there. Okay. And generally, when there's more than one variable, we write them in alphabetical order, but you don't have to. It's just good practice. All right, so you try this one, remembering what I said about smushing and stuff. So for that first distributive thingy-dingy, 3, there's x's on both, so you add the exponents. Only the first one had a y, so you just tack it on at the end. And then when you distribute to the middle term, you do the coefficients. They both have an x and y, so you're just going to add those exponents. One at a time, you do the x first, then do the y. So it's x to the 4 and y to the second. And then distribute it to the very last term. There's no number there, but I know it's really what? 1. So 3 times 1. X to the 3rd power. This one didn't have an x, but you can't just get rid of those, so you just add it on. X cubed, and then y cubed. Okay, I'm glad you asked that. This is exactly what I was going to say next. Once you do those distributives and you multiply, now it switches to a plus or minus problem from yesterday. And you can only combine stuff using plus or minus if what's true about the exponents. They're the same. So what's the answer to your question? No, that's right. Perfect. Oh, that was too much to say again. Very good. Yeah. So even though this has an x and y, and this does, none of them combine because their exponents are all different. Yeah. All right. So here's what we just did. Distributive is we had one term on the outside times 3 terms on the inside. And because we are baby mathematicians and we want to use our vocabulary, what's one term called from yesterday? Monomial. And what's 3 things called? Trinomial. So what are we multiplying here? Dosomials. Binomials, right? They have 2. So we generally say, oh, you're going to FOIL that. First, outside, inside, last. And that's fine. The only downside to FOIL is that only works when you have 2 terms times 2 terms. Then the next section on the back, it'll be even larger expressions. And so what I kind of like to point out about FOIL is you can think of, since we just talked about distributive, you can think about this as just distributive twice. So like if you look at this first term and you just sort of don't think about that 5 for a second, and you say, oh, okay, really, I'm just distributing this y through. Okay, and that would give me y squared plus 8y. Okay, that's one distributive. But then you can put that, now we want to use that 5. Think about the 5 now. And forget about the y that you already did. And now just distribute that 5. And the reason why I point that out, even though you might be thinking, whatever, why don't you just do FOIL? Is because this process you can use no matter how big your problem is. If you go off to school next year and you're taking algebra and your professor wants you to multiply 4 terms by 5 terms, well, that's really just distributive property 4 times. Okay? So it's just another way of thinking about it without feeling like you're learning different things. It's really all the same thing. Yes? Mm-hmm. But because you can't extend FOIL to larger problems, that's why. To say FOIL only works for this specific kind of problem. But to say repeated distributive works for no matter how big or small the problem is. And then you add. Because what will happen is when students get FOIL down, and then I give them something like this, they're like, FOIL doesn't work, now what? So it has limits. Okay, do number 4. In fact, do all the rest of those 3 in that section if you haven't already done them. Tell me if you feel like I made a mistake anywhere, or if you have the same things as me. On 4, I have 8y squared minus 14y minus 15. Are we agreed? Yeah. On 5, it says 18p squared q squared minus 3p cubed minus 55. Agreed? And then 6n cubed minus n squared plus 4n minus 4. Yeah? How come we didn't combine anything there? They all have different exponents, right? All right. So here's what we did. We did 1 term times 3, 2 terms times 2, and now we're going to level up one more time. And 2 times 3. This is a binomial times a trinomial. So, right, FOIL doesn't work on this one because there's no just first, outside, inside, last, because that trinomial has extra terms. So I'm actually going to show you 2 different methods. One is just with the repeated distributive. That's the way I like to do it. And then when we talk about number 8, I'm going to show you box method. Raise your hand if you like box method, if that's something that you use. Okay, these kind of problems, once they get like longer, I think it's a great time to use box method. It helps keep stuff sort of compartmentalized, like literally, so that you don't lose anything. But for 7, I'm going to do my preferred way, which is just repeated distributive. So I'm going to take that first term and distribute it first. So that gives me 2b cubed, 2b, 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 and then b times negative 5b squared, and then 8b. And then what I like to do once the problems get longer like this is after I distribute again, I'll take my like terms and line them up vertically so that they're easier to combine, so I don't lose anything. So I'll distribute the 3. That will give me 6b squared, which I'm going to put right here under that b squared. You don't have to do that. It works better for my brain. And then 3 times negative 5b is negative 15b, and then 3 times 8 is 24. And now I already have my like terms all set up and ready to combine. So I've got 2b cubed plus 1b squared. You don't have to write the 1 if you don't want to, and I don't want to. And there's nothing else that can combine there because their exponents are different, right? Even though most of them still have a b, their power is not the same, so you can't add or subtract. And then for number 8, for all you boxers out there that like the box method, you're just going to make a grid with as many rows as you need for each expression. Like you're going to, in one direction, you're going to need 2 rows for the y and the -3, and the other direction, you're going to need 3 rows because that has 3 terms. So you're just going to make a box. I'm going to put my 3 going like that. And then that trinomial, I put each term above one of the columns. And then going down, I put my binomial with each of those rows. And then you just go left to right and you line stuff up and you do the multiplication. Like y squared times y is y cubed. And then y times negative y is negative 5y squared. And you just fill stuff in as you go along. Yeah, you can do box method anytime you want. And then you just look for like terms. Generally, when you do box method, if there are like terms, they're like on diagonals. Like, see here's the y squareds are on diagonal to each other, and then the y's are. So you want to combine those. The y cubed doesn't combine with anything, so it's just by itself here. And then negative 8y squared, 17y, and then the negative 6. And that's as far as we got last period. Would y'all like to stop here as well? Okay, we'll finish it up and do the practice worksheet tomorrow.